Okay, ZenCode, and this is just a small talk I prepared basically on a pet project of mine called ZenPlayer. So ZenPlayer is a music player written in Kivy because I love Kivy, I love music, and I love building stuff. So I wanted to make a nice toy, and this is that toy. But it's more than just a single application, it's a suite of things that come with it. So ZenPlayer is, at its core, it's a Kivy animated 3D novel user interface screen that runs on Windows, Linux, Mac, Android, and iOS. It's got a VLC backend, which is highly stable. Yeah, X and codec support. There's options for GStream and FFmpeg, but they're not as stable. VLC is by far the most, I think, best audio backend you can use. Great player. Also has an embedded web server, providing a set of API points, complete with Swagger Open API docs, and via a built-in Flasker library. Simple HTML interface where you can basically just do playbacks, but it's and buttons and simple web links, but it's basically more proof of concept. More usable things come in with, for example, the React.js application, which is served by a LAN interface. You can, of course, use Grok if you want to actually run that through the public internet, so you can use your React app basically from the other side of the planet. It also has a Jupyter notebook with its own HTML IPy interface. Yeah, I find the Jupyter notebook Python widgets very nice. They fully basically support generate HTML. They can really make notebooks much more interactive and easier to use. It uses a Firebase event backend as a data source that tracks every play and pause and stop event you do. So that's all recorded and sent to Firebase, so we can do some nice analysis on that as well. But I mean, one of the beautiful things about Firebase is not only does that become a backend, but it also becomes your event store, your event pipeline. You don't need WebSockets, you don't need other complex interfaces. Firebase gives you instant communication through your database, and it's blazingly fast. It's a really next level database, I think. So then it's also got a fast API app that we wrote, which basically generates a Wikipedia URL for the artist that's currently playing. So often you want to find out more about the band, you just hit this URL and it'll send you to the Wikipedia page about the band, so you can read about them. That's deployed by Cloud Run application. We containerize it, just push it to Cloud Run, and so very cost efficient. Only actually use it, pay for the use you get. And of course, then you can from anywhere see what music you're listening to. It provides a set of Jupyter notebooks as well that can monitor your live playing status on any machine using Firebase. It just connects to that, so you can basically from anywhere see what you're currently playing. You can download the last X hundred entries of your play history, and then use that for analysis. We also have a little thing that puts them in BigQuery for that exact analysis, and another notebook with some stat analysis via Panda, like playing time, favorite artists, favorite albums, etc. So it also has a notebook client that uses Firebase to provide almost real-time updates in your notebook of what's playing. So that's the great thing with Firebase. You can just listen on that data change and get, as you play that, you can have a widget anywhere displaying that information. A notebook, okay, we've just done that. Okay, it also has a small script using PinePut, which is a great cross-platform hotkey library for Python, and you can basically set up any machine then in the house to play and pause your music just by hotkeys. So I use keys a lot, so that's pretty important to me. But let's get on to the fun stuff. So this is really at its core, all revolves around this Kivy application, music application. One of the reasons I love Kivy so much is it's fast, simple, and it gives you beautiful animations and interface, and very adaptive because it's built for multiple devices. You can, like the sizing is very effortless, and you can easily accommodate different devices much more intelligently and choose where the fonts stretch or what gets areas by sort of just containers. So that's the sizing aspect. You look, these are the animations you get free because you've got a 3D engine in the background. Kivy gives you various transitions to move between, that are free and very easy to use to move between screens and do things. And the nice thing about that is what makes it feel so much more intuitive is when things are animated. That's how it is in the real world. Objects move; they don't just disappear and appear. So it makes an animated interface feel very natural and pleasant to use for me, and that's my theory as to why. Here you can see the list of artists. You can scroll through. You can also, click to, if you want to play that now. Art Cypress Hill, not right now. Go back. But this is a recycle view widget in Kivy. So it's basically built to handle massive amounts of data. So as your widgets, your label widgets move off the top, they're reused and fed up in the bottom. So you never have more than 20, 25 widgets. And so it's very efficient over huge data sets. So yeah, that's your artist. You can see other art albums by this artist. There's Stephen Corporation, great band. There's the track listing of it. There's our current playlist, which you also touch, and there's just more bit about it. And like for example, CBR, you get the details of the music track. Just one more thing over here. You see, so it also supports keyboard. So you can type in Craig and it'll immediately take you, for example, to an album that starts with CRA. So it's got full key support as well, and hotkey support, so you don't even have to be near the app and to use it. But yeah, so that's the app itself. And I think, the last feature, okay, let's choose a random album for this demo, because I want you to see all of these things actually are live. So let's choose a random album. What should we do? Corner, House of Pain, Portishead. Yes, let's do Portishead. It's something nice, dark and green. So now we play now and replace. So there we've got our Portishead album playing. So that's the app side. Now through the Flask web server, let's go to the simple HTML web face. So there you see you can get the state of the thing. There's our Portishead playing. You can play and pause the app. And it's got full functionality here. Get current info of the track. It's number 1, Cowboys, MP3. So you can do a bunch of stuff from here, but I mean, it's not really an interface you want to go and use. It's just a proof of concept. So one of the things it has, though, is an API. A fully documented API using Flask, as I mentioned before. And Flask, I mean, it's really nice, but it's not near as efficient and not powerful as I think something like DRS Spectacular for Django, because that can automatically use your models to sort of populate your types and returns here. In Flask, unfortunately, you still have to do that as a separate documenting process and build these massive JSON things or into JSON files. So it's very much manual, and it's the best thing you can do for Flask. You can use Marshmallow to do schemas for Flask, but I mean that's an extra layer of complexity. DRF just does that for you, so you get all your types and stuff fed in. It's probably for me the best solution on that scheme is Fast API. The way that works is it's basically type int anyway, so I think Starfish is it, the type engine it uses, but you basically just through your type hinting in your Python code, it determines these types. So you don't even have that, it's just a very nice way to bind it, I think, those things in a Pythonic way. So anyway, here's our Swagger interface. Let's try to get state. There we are, Portishead. Let's listen to the result. Let's execute it. There we go. Portishead volumes playing, so we can get its state there. One of the nice things you can do is also get out its cover. Let's see what that looks like. There you go. It's a small image, not very nice. But yeah, and all this is documented. You can get track metadata. So this basically just documents the API right from Swagger. But it's also not really an interface you're going to want to use. So what it also does is it serves a React interface. This was quite fun to do. It was the first time, but you see this works. You can play and pause, turn up that eerie volume. And here on the left would be effectively what's playing now. You get your bitrate, your VDR. In the center, you get your playlists on the right. And this is also one of the things, one of the reasons why I built this app. I have a very specific way of listening to music and choosing. So sometimes I want a random album. I can just click a button and get a random album. There's one, and then I can add it, play it next, after the next is the next song, play it as the next album, insert, replace. And also, if you want to search for stuff again, let's do. There you go. You can search and find out what albums. If you just press that again, it'll scroll between their different albums or anything that contains the word infect. So that's the React interface. So it uses also the Flexbox control to be adaptive. So you can use that on your phone. It's going to look like that. And then those three panels are just vertically aligned. But they're all there. You just have to scroll. Yeah, so install that on your phone or just open that IP on local network. You've got that ability. So yeah, that's all very nice, but we want to do it in a Jupyter notebook as well. Why not? So we have a Jupyter notebook here. So it's an introduction about what it is. It's very simple to code. You just get a variable binding to the local server there, because you can bind to another server on the network, on any other player. You get this. But this is now confirmed that we're connected to ZenPlayer. Then, success, ZenPlayer is available. And so what we do now is we basically build just a small set of IPy widgets. If you look at the code, is very keen to do this. And this gives you your play, pause, run it. You can turn it up, down through this interface. Yeah, and it looks, I think, pretty nice and very simple to do. I think that's why what really impresses me with the IPython widgets is that they're very efficient, I think, to do, and they're very clean. Very little code necessary. That's, for example, the formatted data, and even this. I mean, I think that is the smallest amount of code I've seen to display an image. It's very, very simple. So, very, yeah. And what do we here? We can combine. You see, because they also have simple containers. Look, it's not the most flexible widget system. If you want to do anything graphically specific, then you're going to fight a losing battle. This is just for simply mechanically laying out things in a prettier way than just printing. That serves information, or you can do it in a whole shebang. So here we've got the widgets. You can play, pause here, and you can drop down that current playing. So that's all very nice. That's all running locally so far. So let's go to where we write our stuff to Firestore, because that's where a lot more of the nice stuff comes in. And here I think this is one of the things that shows how, I think, powerful Firestore is. You see here now playing, you see it's Portishead, and if you look at the speed of the updates, when I pause that music, it's really quick. And that, of course, event gets as quickly distributed to any client you want. So it's like real-time communication around your data. It's really powerful. So that's the Firestore one. But now, okay, so great. Now it's in Firestore. What the hell are we going to do with it? So first we check out this the Fast API application, which runs using Cloud Run. So it's there, and it's only spun up when you need it to be. But you see there, we ask for that URL. It's going to take a little bit because I haven't used this for months. But that's free. See, it shows you Portishead, Zen, and you want to go to About Portishead. Let's hope Portishead, bang. There we go. So that's pretty nice to have, because you can just leave it anytime I want to know about that thing. I just go to that URL. Okay, so that's pretty cool, but we also want to do a little bit more. So how about playing with some Firebase stuff? So here we go, configuration, because just installing and stuff. First we set up our Google credentials. Google credentials found. Just a little setup here. This isn't much code. The doc strings are just very big. I can be quite verbose. I think possibly sometimes too much. But yes, there we load up Firestore objects. So now we've got a live basically connection to our database. And we do a pretty print. What do we do? We get there, Firestore, we get docdict, and we see, it's Portishead playing. Number 2, all mine. Okay, and then let's fetch the last 100, get a bit of a history. I think I brought it down to 500, but you can make that anything. And you can see here all the different things playing. And then what do we do with that? What do we do with that? We monitor the Firestore document for changes. Now that we know we can get data from it, when we run that, we'll see, you see that says playing there. And then when I go here, it's paused. Go there, it's playing. So that's what I meant by that, this live panel. that you can have in your notebook, or in any place really. Firestore gives you real freedom in that respect. Then let's do something else. Let's write out like a list of our, no, we have to have the music playing, sorry. Okay, so let's go and download a list of CSV file. We've got to set our list of 100 here. Is it uploaded? Yes. Let's go to the end. Yeah, that looks happy. So now we're going to upload that CSV to cloud storage. Pretty much standard Google stuff here. So that's uploaded, or starting to upload. File uploaded to bucket. Okay, so that looks like that worked. Okay, then this is a code you only need to do once. It just sets up your BigQuery mapping to your external table. But we don't need to do that. That's been done for us. So what we're going to do is we're going to basically then query. We uploaded them to BigQuery, and then basically get counts of the artists and get distinct. So there we see the embarrassing list of music I listen to. Yeah, some interesting ones there. Everyone has challenges, lovely. Okay, then what we can also do now with that CSV is we can do a Pandas analysis. So we run that, we put them into a nice table, make a data frame from the doc history, and there we've got Portishead's thing, Dion Hill's various, that's probably a collection. So there you can see music with tables, and you can start obviously doing all your Pandas magic and analysis here. I think this is now sorted by playing time, or it adds the playing time, so you can see how long you've actually listened to that artist for during that entire period. Then we could, this is an interesting one. We end with the climax of group by artist, doing a query basically that shows you the artists you listen to the most, and well, within this time keep the period that I've the last 500 entries. But yes, so that's pretty much it. Like it lets basically ZenPlayer do everything I want to do with my music in the way I want to do. Everything's controlled. It uses great. I mean, I did a lot of those things to also just learn and do new stuff, but also add to the project. But yeah, I hope you like that. Thank you for listening. If anyone has any questions, feel free to pop me an email or something. Cool. Thank you very much. Ciao. Ciao.